Alright guys, we're starting on chapter 46, which is cardiology procedures. Basically, this is, the whole entire chapter talks about EKGs, Holter monitors. I'm going to be jumping back and forth between about 3 different PowerPoints. This video may end up being a two-parter, because this is quite a bit. So, we're going to start by going to, this little PowerPoint right here, and we're going to look at this page real quick. We're going to cover cardiology when we get to the anatomy portion, but I just want to, before I start talking about this, just kind of give everybody a quick little refresher over your heart. So as you remember, you have two sides of the heart, the right and left, and that is separated by the ventricular septum. The right side of the heart deals with deoxygenated blood, and the left side of the heart deals with oxygenated blood. So as we remember, blood comes in through the superior inferior vena cava, into the right atrium, through the tricuspid valve, into the left ventricle, through the pulmonary valve, out the right and left pulmonary arteries where it goes to the lungs. It'll receive oxygen at that point, come back to the heart via the right and left pulmonary veins, into the left atrium, through the bicuspid or mitral valve, into the left ventricle, through the aorta, out to the rest of the body, delivering oxygenated blood. We've talked a lot about this, especially if you've had me, health science and diagnostics. So the next part of this is the electrical conduction system. That's what the EKG looks at. So let's just take a minute here and just, what is an EKG? EKG. Come on. My computer's being slow. I've got like 15 programs open right now. Okay. At any time, I'm going to go through this really fast, so just pause it, rewind it, whatever you have to do. But basically, EKG is nothing but a machine. They look various, depending on which company makes them. I have 3 different examples in there in the lab, which you'll all get to use. But basically, it measures and records the electrical impulses within the heart. Okay, so there's several different parts of the machine. There are electrodes or sensors. That's the things that we put on the patient's chest. There's wires that are connected from the machine to those electrodes. The amplifier, the galvanometer, and the stylus are all located within the EKG machine, and that's what picks up the signal, makes the markings, and collects the electrical impulse. Okay, so why do we use an EKG? Well, we do EKGs on patients for several different reasons, but EKGs can detect all of these things. So myocardial infarction, cardiac arrhythmias, heart enlargements, effects of medications on the heart, and then electrolyte imbalances. So we will do EKGs on people to get a baseline. Here we go, for a physical exam. So you always want to get a baseline, and we'll talk about this when we talk about blood drawing as well. It's good to have a baseline. So that's, the norm for you before, heart disease kicks in. So usually at around age 35, maybe 40, it's great to have one so that whenever heart disease problems come along, you know what your heart should be looking like. Okay. They'll do that for the baseline. Again, to determine hypertension. If you're a smoker, you should get EKGs done. If you have high cholesterol, if you have obesity or known heart disease. Okay, so, the EKG, again, like I said, I'm not going to get into all this stuff right now. Oops. The limb leads and the precordial leads. But this is what those, little electrodes are, those little sticky things right there. And these are the wires that it was talking about. Okay, like I said, I'm going to be jumping around from PowerPoints. So, to understand how the actual EKG works, we've got to talk about the electrical conduction system. So we're going to start talking about this at the cellular level of the heart. So, again, this is how the EKG actually works if you're taking notes here. And this is at the cellular level. Okay? both electrical activity and mechanical contraction occurs at the cellular level. So we've talked about this before. The heart actually is a muscle, and it physically contracts, okay? Each cell within the muscle of the heart contracts. And those cells within the muscle are known as a myocyte, okay? A myocyte is the cardiac cell that actually does the squeezing, all right? Electrical impulses are transmitted rapidly from those cells to cells, causing the contraction, and the end result is the entire muscle contracts. So again, here's a little vocabulary for you. An electrolyte is an ion or a small particle that is positively or negatively charged. And those electrolytes can be sodium, potassium, calcium, or chloride. Okay. Extracellular is a part of the cell. The fluid and particles, it's the outside surrounding part of the cell where fluids and particles are, okay? Intracellular is a word we use for things that are inside the cell, within it, okay? The cell membrane is a layer of protein that surrounds the cell and keeps it separated, the fluids and all that kind of jazz, the intracellular from the extracellular. And then again, the myocyte is the actual name of the cardiac cell. Okay. Millivolt and volt, that's the measurement used for the electrical potential. So we measure everything in millivolts, MVs. Okay. Alright, so how does electrical stimuli happen? So the electrical ions cross over that membrane and they become positively and negatively charged. Okay? So sodium is the most abundant electrolyte in the extracellular. So on the outside of the cell, draw a circle on your paper right now. Okay? On the outside of that circle, write sodium. Okay? On the inside of that circle, I want you to write potassium. And do we know the abbreviations for sodium? Sodium is Na and potassium is K. So we write Sa on the outside and K on the inside of that circle. Okay? Most abundant on the outside, sodium. Most abundant on the inside is potassium. Alright, so you should have your circle drawn, and you've got the Na on the outside and a P on the inside. So sodium is stronger. It has a stronger positive charge than potassium. So that makes the outside of the cell positive electrically, and inside the cell it makes it negative. Okay? And this is at resting. Keep that in mind. This is a big kicker right here. This is at rest. This is not when the cell is contracting. So what am I talking about right now is the myocyte. So above your little circle, write myocyte, and you should have Na on the outside, which is sodium, with a positive sign, and K or potassium written on the inside of it with a negative, because when potassium is inside the cell, potassium is negative. When sodium is outside the cell, it is considered positive, okay? And this is at resting position. Okay, so for electrical conduction to occur, an exchange between the ions or exchange between those particles has to happen across that cellular membrane. So there's 3 phases at which this happens. And those 3 phases are called polarization, depolarization, and repolarization. So what you just drew on your piece of paper right there, with sodium on the outside, potassium on the inside, that was at polarization. That's what that's called, resting. Okay? So you can go ahead and write that at the top. This is the cycle of a myocyte to get contraction of the heart. And during polarization, sodium is on the outside positively charged and potassium is on the inside negatively charged. So we're going to talk about each one of these phases. Okay? We've already talked about polarization. Again, it's at the resting state. It's when a balance between the electrical charges on both, so there's a balance on both sides. And that means there's no movement of the ions. The ions are stationary. Sodium is on the outside, potassium is on the inside at this point. Okay? Phase 2, when depolarization happens, okay? Sodium and potassium trade places. So I want you to draw another circle right beside that. Label it depolarization. Put sodium on the inside and potassium on the outside. Okay? So when sodium moves inside, the inside of the cell becomes positive and the outside becomes negative. So then that cell becomes positively charged. Okay? So this is depolarization. Third phase is repolarization. The channels switch again because sodium enters the cell. Because calcium enters the cell. Sodium leaves and potassium re-enters the cell. Okay, so then it becomes positively charged on the outside, negative charge on the inside. Sodium is on the out, potassium is on the inside. That is considered repolarization. Okay? Polarization, depolarization, and repolarization are the events that the actual machine records. Okay? If there's a disturbance in that cycle, it can mean various conditions such as ischemia, injury, infarction. So let's just look at that again. Okay? Polarization is when it's resting. So you should have your one circle there. Potassium on the inside negatively charged. Sodium on the outside positively charged. Nothing is moving. Everything is stationary. Then it moves on to depolarization. Sodium moves to the inside of the cell. Potassium moves to the outside of the cell. The cell becomes positively charged at this point. And then you should have a third circle drawn with sodium re-entering the outside of the cell, potassium re-entering the inside of the cell. Okay? And these three things is what is recorded on every EKG. This whole cycle. And this whole cycle happens thousands of times every minute. Okay? Okay, so that was on the cellular level of how the actual heart muscle contracts. So how does that get stimulated? So here, we're going to talk about the SA node. The SA node, located in the right atrium, is the pacemaker of the heart. Okay? It's where an electrical impulse is generated. Oops. Okay. The SA node is the pacemaker of the heart, like I said. The node is a specialized conductive tissue that creates the electrical impulse. Okay? So when your SA node is firing, and in firing properly, your heart rate should be between 60 and 100. Okay? This is what is known as sinus rhythm. I know you guys have heard this on Grey's Anatomy and all that kind of stuff. You know, we have sinus rhythm after they've shocked somebody or something like that. So, anyhow. But a fun fact down there at the bottom, the SA node is rich in nerves, so when you get emotional or you're exercising or anything, obviously your heart rate goes up, and it is because the SA node is told to increase your heart rate. Alright, so again, SA node is located in the right atrium. It's the pacemaker of the heart. When the SA node is firing correctly, your heart rate should be between 60 and 100, and it's known as sinus rhythm. Okay. The second part of this, the electrical impulse starts at the SA node. Then it travels, as you can tell by the arrows, down to this AV node. Okay. Atrioventricular node. It holds the electrical impulse for just a second. And it lets the atria, contract and deliver blood into the ventricle before it sends on the electrical impulse, okay? We're going to talk about this a little bit more in a little bit. The AV node is considered the backup for the SA node if it fails. So if the SA node doesn't fire, the AV node will fire, okay? And the impulse leaves the AV node and travels down through the bundle of his. Okay? So we've gone electrical impulse SA node, AV node, Here is the bundle of his. All right. And then its bundle of his splits into the right and left bundle branches. Okay.